Okay.
Now I'm back.
Quick reminder, by joining the class today, you consent to being recorded. And remember, all of these recordings are available. So if you want to go back and revisit the recordings, of course, you could do that. All right, folks, so here's our calendar. We were going to today just do a few more examples from the practice test, then get started in section 10.1, and then we'll continue section 10.1 on Friday. So here on the calendar, it shows that the chapter 9 test in WebAssign is due this Sunday. Remember, all of these due dates in WebAssign are actually pushed out until May 1st. So you don't have to finish the test by April 5th, but I would say you should try to keep on schedule here so you don't fall behind. And also, it's a good idea to work on this test while these concepts are still fresh in your mind. Okay, so I would say once you review the practice test and you're feeling comfortable with the practice test, it'd be a good idea to take the actual test in WebAssign. Remember that actual test is 15 problems. Here are the tests. 15 problems, 2 hours. So you do have to be, ready to work efficiently. And you have to really know the concepts going in to the test. All right, folks, so let's do the practice test. And I'm going to keep this chapter 9 summary handy because we might need this chapter 9 summary. All right, so I'm going to problem 9. It said simplify the expression cosine squared 14 degrees minus sine squared.
Oh, for that one, you have to do 14 times 2. You have to do.
Yeah, so notice it says simplify the expression, do not evaluate. So what I need to do is look for some formula that matches up to this expression they're giving me, and I can use that formula to help me simplify. Well, when I go to this chapter 9 summary, I'm noticing here is a cosine squared minus sine squared right here. So all I have to do is recognize that in the example they're giving me, theta matches up to this angle 14 degrees. Well, this expression is equal to cosine 2 theta. But in our example, theta was 14 degrees. So this is just going to be 2 times 14 degrees. So the answer here is just cosine 28 degrees. And notice the problem said do not evaluate, meaning just leave the answer as cosine 28 degrees.
Also for 10s, it's going to tell the same thing.
Yep, number 10 is going to be similar. Now, folks, remember, when you enter this answer in WebAssign, be sure to enter the degree symbol with your answer. If you don't enter a degree symbol, WebAssign thinks you're entering radians as the units.
Number 10?
Yeah, let's go to number 10. By the way, I just want to mention, I could not, you might say, well, why don't we use cosine squared plus sine squared for this problem? And of course, I would use sine squared plus cosine squared if possible, but this is not cosine squared plus sine squared, it's cosine squared minus. So that's why I had to use this formula that was a match to the expression they gave me. All right, let's go to number 10. Number 10 is a similar kind of setup. They're giving me 2 cosine squared 13 degrees minus 1. So my job here is to try to match that expression to one of the formulas. And I'm noticing right here is a match that says that cosine 2 theta is equal to 2 cosine squared theta minus 1. All I have to do is recognize that in our example, theta matches up to 13 degrees. So this expression is the same as cosine 2 theta, but in our example, theta is 13 degrees. So this is cosine 2 times 13,
26.
which is cosine 26 degrees. Yep.
Number 11.
Let's go to number 11. So folks, when you do some of these examples on the exam, hopefully these examples are only going to take you a very short amount of time.
Like less than a minute.
Yeah, I would say less than a minute because you don't really have to do much computation at all for these. All right, let's go to number 11. Number 11 is a little different because number 11 says use the power reduction formula to rewrite the expression. Notice it says hint, your answer should not contain any exponents greater than 1. So what they're asking me to do is take this cosine squared and rewrite it using either sines or cosines, but I should not have any exponent 2's anymore in my final answer. Well, in the chapter 9 summary, there are these, they're called power reduction formulas. What it means is you're allowed to go from an exponent 2 down to an exponent 1 by using this formula. So I have a cosine squared 7x. Well, here's a formula that matches up for cosine squared. All I have to do is recognize that in my example, theta is matching up to 7x. So I'm going to rewrite this as 1 plus cosine 2 theta. But my theta was 7x. And this is all over a denominator of 2.
So that's the answer.
I could just clean it up because inside the parentheses, 2 times 7x is 14x. All over 2. So this should be the final answer for this one.
I mean, WebAssign will take a WebAssign.
WebAssign should take the answer like this. Yep.
Number 12.
Let's go to number 12. Again, folks, this should not take you too long, hopefully, because many of these questions you can see are really pattern matching. You're taking the example they're giving you and trying to match it to one of these patterns on the chapter 9 summary. Right, so
Now
remember,
for that one, we need when you have to use the product to sum formula.
Yep. So let's go to number 12. Notice here it says rewrite the product as a sum or difference. So that, these instructions really give you a good hint as to what formula you need. Because notice it says I want to go from a product to a sum. And notice right here in this section are the product to sum formulas. So all I have to do is look at this expression they're giving me. Notice it's a sine times a sine. Let me match that up. Well, here's a formula that matches up to sine times sine. All I have to do is recognize that alpha matches up to 20x and beta matches up.
A is the alpha.
Yep, alpha is 20x, beta matches up to 11x. All right, so let me go plug in. Now I just got to be careful because notice there's a 20 in front of this expression. So don't forget the 20, I'm going to bring it down with me. Now I'm going to plug into this formula. When I plug into the formula, it's 1/2 in brackets cosine alpha minus beta. But our alpha was 20x and our beta was 11x. Okay, that's the front. Let me go to the back cosine. The back is cosine alpha plus beta. So that's going to be cosine of 20x plus 11x. Let me move this over. And I'm almost done. I'm just going to clean this up now. In front here, notice I have a 20 times 1/2. So, of course, I can multiply that to get me a 10. And then inside the parentheses here, 20x minus 11x, that's just 9x. And in the back parenthesis, I have a 20x plus 11x. So that's 31x. And of course, be careful, you still need these brackets here.
Wait, to get 20, you have to do 20 times 1 will be 20, then 20 divided by 2 to get 10 then.
Yep, exactly right. So in front here, you can think of this as 20 over 1 if you want. And then this is multiplying fractions. On top, 20 times 1 is 20. On the bottom, 1 times 2 is 2. And 20 divided by 2, of course, is just 10. All right, folks, don't forget these brackets here. You could use parentheses instead of brackets, because this 10 has to multiply this entire expression here. If you wanted to, you could take the 10 and let it multiply inside the parentheses using distributive property. You could do it that way. So I could also write this as 10 cosine 9x minus 10 times cosine 31x. So either one of these answers would be okay for WebAssign.
And plus, like, there was like a different answer when I was answering for number 12.
Yeah, remember, every student's going to have a slightly different example. Your numbers will be a little different.
Oh, the
By the way,
question was the same.
yeah, the numbers when they're shown in, if you look here in this problem, whenever the numbers are showed in red, that means WebAssign randomizes those numbers. So your numbers might be different than this example, but of course it's going to be the same procedure to work through.
13.
Let's go to number 13. All right, number 13 says rewrite the sum as a product. And again, read the instructions very carefully here because that's going to tell you the formula you need. Notice it says go from sum to product.
So we have to do the first one, sine A plus sine B you have to do.
Yep, so I'm going to use these formulas that are sum to products. All right, it looks like I have a sine plus another sine. Well, Gennaro says it's this formula here that matches up. Yes, exactly right. So I'm going to use that formula. The only thing I have to do is match up alpha and beta. So let me match up the alpha and beta. In my example, it looks like alpha matches up to 3x.
Then the beta is 7.
Beta is 7x. Yep. So let me go ahead and plug into the formula. I'm going to write this as 2 sine, and then it says alpha plus beta over 2. In our example, that's 3x plus 7x over 2.
Then for the cosine, I got negative 2x, but make it positive 2x.
Yeah, so here it's going to be 3x subtract 7x over 2. All right, now I'm just going to simplify inside the parentheses. In the first parenthesis, on the top there, it's 3x plus 7x. But of course, that's 10x. And 10x over 2 is 5x. In the back parenthesis, I'm going to have a cosine. And notice on the top, when you subtract 3x, subtract 7x, that's negative 4x.
Then negative 4 divided by 2, and then you get negative 2x.
Right, so negative 4x divided by 2 is a negative 2x.
And that's how we get the positive 2x. If you replace
Yeah,
it.
so now, you know, I usually want to get rid of negative angles. I don't like cosine of a negative angle. So let me go back to the chapter 9 summary for a second. And if I come up here, I'm noticing that when you have the cosine of a negative angle, you can really replace it with cosine of the positive angle. So cosine negative 2x is really the same as cosine positive 2x. So I can write the final answer here as 2 sine 5x and cosine positive 2x. And the reason we do this is we just don't want to leave answers with negative angles if possible.
Okay, now we can do 14.
All right, let's go and do a few more. Now, 14 is an example of why you might want to use these formulas. You might say, well, why do you want to change from a product to a sum anyway? And again, I'm reading the instructions carefully. And if I read the instructions carefully, I notice it says, go from a product to a sum. Well, if I was going to try to work this out, notice cosine 15 degrees is not on the unit circle. But if I use one of these formulas, maybe I'll end up with angles that are on the unit circle. All right, well, this example is a cosine times another cosine. Well, that matches up to this formula right here.
Alpha is 45, then beta is 15.
Yep, let's label alpha is the 45 degrees, beta is the 15 degrees. Okay, so now I'm just going to plug into this formula. It's 1/2 bracket cosine of alpha minus beta. Well, that's going to be 45 degrees minus 15. And then plus cosine alpha plus beta. And that's just 45 plus 15 degrees. Well, the good news now is these angles are going to end up being on the unit circle. So let's go ahead and work this out. By the way, remember this 1/2 is sitting in front of these brackets. All right, well, this first parenthesis, 45 minus 15 is 30 degrees. And the second cosine inside the parentheses, 45 plus 15, that's 60 degrees. Good news, 30 and 60 are on the unit circle. So now I can go to my unit circle. Cosine 30, I'll bring up the unit circle here so we have it. Here's the unit circle. Cosine of 30 is here.
Square root 3 over 2.
Yeah, remember cosine is the x value on the unit circle. So this is going to be square root of 3 over 2. And cosine 60, I'm coming over here. Again, remember cosine is the x value. It looks like that is 1/2. All right, well, let me finish this up. Inside the parenthesis, inside the brackets, I have a common denominator. So I can add these two fractions inside. To add fractions, you keep the denominator the same and add the top part. And to finish this off, now I can multiply the fractions. If you multiply fractions, you multiply across top and bottom. So it looks like the final answer here is going to be the square root of 3 plus 1 on top. And on the bottom, 2 times 2 is 4. And of course, remember, you want to leave your answer like that. Don't work it out on your calculator because WebAssign is looking for an exact answer. All right, folks, any questions on these examples?
15.
Yep, you can probably see that these examples were really based on matching the problem that you were given to one of these different formulas that are on this Chapter 9 summary. All right, folks, let's do a couple more here to wrap this up. Let me go to this last type of problem. So the last type of problem here is finding solutions to trig equations.
There's 17 questions in total.
Yep. So let's do number 15 here. It says, find all solutions on the interval between 0 and 2 pi? Well, you remember what you have to do on these kinds of problems is first determine if the equation's linear or quadratic. Linear means it's just sine to the exponent 1. Quadratic would be sine to the exponent 2 or cosine to the exponent 2. Well, in this example, number 15, it's linear because I'm seeing it's just sine to the exponent 1. So what you want to do is get that trig function by itself on one side of the equation. So I'm going to divide both sides by 2. And that gets me that the sine of theta is negative square root of 2 over 2. Remember, this is asking you what angle. Remember, on these problems, you're trying to find theta. You're trying to find angles. So your answers here are angles. It's really asking you what angle has its sine equal to negative square root of 2 over 2. Well, for that, I'm going to use the unit circle to help me out. So I'm going to go look around the unit circle where the sine is equal to negative square root of 2. Remember, the sine is the y value on the unit circle. All right, so I'm kind of scanning around looking for where the y value is negative square root of 2 over 2. Well, here's one angle. Looks like this answer is 225 degrees. Of course, you could write the answer in radians if you wanted to. And is there another angle?
Let me have a look.
Remember, for these problems, there could be more than one answer.
315.
Yep, so I'm coming over here. Here's another angle that has the y value equal to negative square root over 2. So it looks like this answer is 315.
Yep, that's all it is.
And that's it. I can't come up with any other answers. Of course, if you prefer to write your answers in radians, this would be 5 pi over 4 for
And
the
7
one
pi over
angle.
4.
Yep, and 7 pi over 4 for the second.
WebAssign will take either one then.
You can either enter your answer as degrees or radians. WebAssign will take either one. If you do enter your answer as degrees, though, please remember that you have to put in this degree symbol as part of your answer.
16 now.
Okay, let's go to number 16. By the way, folks, if you work through the exam and you're looking over your results after you submit, and you got the problem wrong because you forgot to put the degree symbols, email me or contact me. I can go in and give you credit for that. I don't want you to lose points just because you forgot to enter degree symbols. You really had the right answer. It's just that you didn't put the answer in the way WebAssign was looking for. All right, folks, let's go ahead and do the rest of these examples. All right, here's another one that's asking me to find all solutions to this equation. Now, for this equation, there's actually two trig functions. Notice there's a secant and a sine. So when you have two trig functions like this, you want to try to factor if possible. So I want to try to factor here if I can. Well, I'm noticing that I can factor because there's a sine x in the first expression and another sine x in the second expression. So let me take a sine x and pull it out in front. This is kind of like a greatest common factor, if you remember that from algebra. If I pull out a sine x in front, it's going to leave me with secant x subtract 2 inside the parentheses. All right, well, now that I've got it factored, I'm going to use a property from algebra that says if you have one quantity times another quantity equal to 0, you're allowed to set each quantity separately equal to 0. So now I'm going to break this up into two equations. The one equation is going to be sine x equals 0, and the other equation is going to be secant x minus 2 equals 0. You probably remember this when you were solving quadratic equations back in algebra. All right, well, now I'm going to try to solve each one of these equations separately. All right, let me go to secant x equals 0. So I'm going to go to the unit circle and look, where is the y value equal to 0 as I scan around the unit circle?
It's 0.
Here it is. Here's one answer. So it looks like 0 degrees is one answer here for this angle. Any other angles?
180.
180. Because here is another y value that's equal to 0.
There's also a 360 over there.
Well, Gennaro, there is 360, but here's the problem. I can't use 360 as an answer. The reason is this condition they gave me as part of the problem statement. They said your answer has to be between 0 and 360. Let me write this in degrees to make it a little easier. Here's what they gave me as the conditions for this problem. They said your answer has to be between 0 and 360. But when they put this bracket on the 0, that means including 0 itself. So that means an answer of 0 degrees is allowed. But when they put the parenthesis on the 360, that means 360 itself is not allowed. You might remember this from interval notation. So 360 itself, 360 as an answer is no good.
So I'll just 0 and 180.
Yep, not allowed. You could have an answer of 359.99 degrees. That's okay. But the answer of 360 itself is not allowed. All right, let's go over to the right side. I'm going to add 2 to both sides on this equation. And that's going to give me secant x equals 2. But I can't really use secant x with the unit circle. So I'm going to replace secant with its equivalent. So I'm coming over here. Notice here it says secant is 1 over cosine. So I'm going to replace secant with 1 over cosine. So this is going to be 1 over cosine x equals 2. And I want to solve this equation. Well, let me make 2 into a fraction by putting it as 2 over 1. The reason I did that now is I have one fraction equal another. And anytime you have one fraction equal another, you can cross multiply. So I'm going to multiply this way and set it equal to the multiplication this way. So that's going to be 2 cosine x equals 1 when I cross multiply. I'm going to divide both sides by 2 to get cosine x by itself. So that's going to give me cosine x equals 1/2. All right, well, now I can go to the unit circle and go back to the unit circle. And if I go back to the unit circle, now I'm looking for any angles where the x is equal to 1/2.
X is for cosine.
X is for cosine. So
60 degrees.
Yeah, I'm noticing here is 1x, that's 1/2. So that tells me one answer here is 60 degrees.
Then the other one is, let me have a look. Then the other one is at 300.
Good, right? If I come down here, I'm seeing another x value that's 1/2. So that means another answer is 300 degrees. So folks, for this example, there were 4 correct answers. Right? 2 solutions for the one equation and another 2 solutions for the other. So altogether, 4 answers here. All right, folks, please, of course, let me know if there's any questions.
17.
Let's go to the last one, number 17. All right, now this one's a little tricky because you might notice this kind of looks like a quadratic equation. Well, I know it's quadratic because I'm seeing a cosine squared in the equation. Well, what I'd like to do as the first step is get this set equal to 0. You might remember this is the way you solve quadratic equations in algebra. So I'm going to subtract 1 from both sides of the equation because I want to get the equation set equal to 0. So that's going to leave me with 2 cosine squared plus cosine t minus 1 equals 0. All right, now I've got to try to factor the one side of the equation. Well, this is going to be a little messy to factor. Now, here's an option. An option is, instead of working with cosines, how about if I use a substitution where x is equal to cosine t? I don't have to do this, but the reason I'm going to do it is to make the factoring a little easier to navigate. So now I can write this equation as 2x squared plus x minus 1 equals 0. All right, so now let me try to factor this. Because if I can factor this equation, I'll know how to factor the equation that has the cosine squared in it. Well, if I have a 2x squared here in front, the only way to break that up is to make a 2x and x, so that when I multiply this 2x times x, I get back to that 2x squared. I'm also noticing that the constant here is a negative 1. So in the back of these parentheses, I need 2 numbers to multiply to get me negative 1. Well, the only way that can happen is if one number is positive 1 and the other number is negative 1. But here's the problem. I don't know whether I should put a plus 1 in front like this, or if I should set it up to be a minus 1 in front like this. So these are like 2 options that I've got to kind of check out to see which option is the correct way to factor. So how am I going to tell whether to go with option A or option B here? Well, let me do a quick FOIL multiplication and see which option gets me back to the original expression that I started with. All right, so I'm going to do a quick FOIL multiplication here just to check it out. All right, when I multiply 2x times x, I know that's 2x squared. Then I'm going to multiply 2x times negative 1 in the back. That's minus 2x. And then I'm going to multiply this plus 1 times x. That's plus x. And finally, plus 1 times minus 1 is a minus 1. But I'm noticing when I combine these middle terms, it's a negative 2x plus x. That's going to get me a minus x in the middle. But that's no good. I need a plus x in the middle. So that tells me this option A is no good. If I do the FOIL multiplication on option B, it's going to end up being 2x squared plus 2x minus x minus 1 equals 0. And you could probably see that these like terms here in the middle work out to be plus x. So I know this is the correct way to do the factoring. So the factoring here was a little tricky. You had to be careful to get the signs correct. Well, let me go back to our original equation because now I know how to factor this. Well, remember, x was cosine t. So when I see 2x minus 1, that's really 2 cosine t minus 1. And the second parenthesis was x plus 1, but that's cosine t plus 1. Remember, I just used the x's here to make it easier to factor, but I have to go back to the cosines for the original expression. All right, well, now I have one parenthesis times another parenthesis equals 0. I can break this up into two parentheses equal to 0. So this is going to be 2 cosine t minus 1 equals 0. And then this is going to be cosine t plus 1 equals 0. All right, I'm going to solve each one of these equations separately. On the left-hand side, I'll add 1 to both sides here. That leaves me with 2 cosine t equals 1. Divide both sides by 2, and that gets me cosine t equals 1/2. All right, well, I can go to the unit circle. I'm going to look for where the cosine is equal to 1/2. Well, that's the x value. So here's one answer, 60 degrees. And there's another place where the x value is 1/2, way down here at 300 degrees. All right, so those are two answers, but I have to still go and solve this other equation here. Let me subtract 1 from both sides here. That means cosine t is equal to -1. Let me go to the unit circle. I'm looking for the x value on the unit circle equal to -1. And it looks like this is the only angle that has a cosine equal to -1. So on this side, the answer looks like it's 180 degrees. So in this problem, it turns out there's 3 answers, 3 angles. You can always enter these answers in radians instead of degrees. That's up to you.
That's it.
All right, folks. So a couple of these problems, you really have to go back to your factoring days. And remember, if you want to check your factoring, if you're not quite sure, what you can do is do a FOIL multiplication, right? Multiply the parentheses back and ensure that you get back to the starting equation. It's like a double check that you really did the factoring process correctly. All right, folks, any questions on the practice test?
Nope. Now I'm ready to go.
All right, folks, please, between now and Friday, please work through the practice test if you haven't done it already. Ask more questions on Friday's class. We could do more. We can go back over any of these examples if you would like. All right, well, for right now, I wanted to introduce section 10.1 in the time we have left. All right.
Law of signs.
Yeah, it's called the law of signs. And here's the reason we need law of signs. If I was working with a right triangle like we've been working with in this course, you remember that the sine of an angle, like let's say sine theta, was equal to opposite over hypotenuse. So for example, let's say the sides here were 3, 4, and 5. Well, in this example, this side 4 is the opposite side. This side 5 here is the hypotenuse. So the sine here would be 4 over 5. So we did many examples like this. But this formula only applies for right triangles. Remember, that means a triangle with a 90-degree angle. Because remember, a hypotenuse only exists in a right triangle. If I go to a non-right triangle, there's no such thing as a hypotenuse anymore. So what do you do if you're trying to analyze a triangle that's not a right triangle? That's where law of sign comes in. It's for use with triangles that don't have a right angle. Okay? We call these oblique triangles. An oblique triangle is just a triangle that doesn't have a right angle. All right, so what we need to do then is look at either two options. So if you're going to solve or work with triangles that don't have a right angle, you're going to have two options. Either we can use law of sines, and that's what we're going to talk about now, or we can use something called law of cosines. We're going to talk about that next week.
Is there a formula sheet for this one?
There are formulas on the slides here. Janara, I don't have a formula sheet, but you know what? I'm going to make one up. So I will make up a formula sheet for chapter 10 and email that out. That's actually a good idea.
Mm-hmm.
All right. So here's what we're going to do. When you're solving a non-right triangle, you're going to start out trying to use law of sines. So I'm going to say use this method first, because you're going to see law of sines is going to be easier to use versus law of cosines. So use law of sines first. But it's going to turn out law of sines will not work in every scenario. So what if you can't use law of sines? It doesn't work. You'll go to law of cosines as your backup plan. And law of cosines is more complicated. So I would only use law of cosines if I couldn't solve using law of sines. Okay, so I was going to say here, use second. All right, well, what is it we're trying to do anyway in this section? What we want to do is say we're going to solve a triangle. What that really means is you want to know what are all the sides and angles. So let's say I give you a triangle. Let me draw a little triangle here. I'm going to purposely draw it so it's not a right angle. So notice this triangle I drew to not have a right angle. I want to know what are all the side measurements. You know, let me call this, let's say, side A, B, and C. I want to know what are the lengths of these sides, but also I want to know what are the angles. So I also want to know what are these three angles. So when it says solve a triangle, you really need to come up with 6 answers. You want to know the lengths of the 3 sides, and you want to know the measurements of the 3 angles. So 3 sides, 3 angles means 6 answers to these questions. But to work this out, you have to know some information to begin with. So you're going to be given 3 quantities in these problems. It turns out if you know any one side and then 2 other measurements, like 2 sides or 2 angles, you can figure out all 6 unknown quantities. All right, so you're going to be given a few known quantities, but then it's going to be up to you to figure out all the unknowns. So let me show you what law of sines looks like. Law of sines is a formula that looks like this.
Okay, let me just write it down real quick.
So law of sines is actually 3 fractions set equal to each other. And we're going to use this format. And sometimes I'm going to write the law of sines using alphabetic characters instead of Greek. I just think it's sometimes easier to use A, B, and C instead of alpha, beta, and gamma. So sometimes I'll write law of sines like this.
For? The Y stands for.
Oh, this letter here, this is a Greek letter. It's not a Y. Gennaro, I know it looks like a Y, but it's not a Y.
It's gamma.
It's a Greek letter called gamma. And that's why I don't like you to use these Greek letters, because I think it's a little confusing. So instead of using Greek letters, if you want to just think of law of sines like this, it might be a little easier. So now when I do this, the sides are always lowercase letters. So notice the sides are going to be lowercase letters. The angles are going to be uppercase letters. So we're going to use this convention. that the angles will be uppercase ABC, and the corresponding sides will be lowercase ABC. All right, now when you use this formula, you're going to be taking any two of these fractions and setting them equal to each other. So for example, you could take sine A over A and set it equal to sine B over B. That's one option. You could take sine B over B and set it equal to sine C over C. That's another option. And the third option, you could even write it as sine A over A equals sine C over C. So you can set any two of these fractions equal to each other. That's allowed. Now, when you're working an example, how will you know which two fractions to set equal to each other? Well, it's all going to depend on what information is given to you in a problem, and we'll do some examples on that in just a minute. All right, but before we get to examples, I want to mention to you something that's important. When you're setting up these problems, you've got to draw a diagram. Very important to draw a diagram. If you don't draw a diagram, it's going to be very confusing. And let me draw a diagram using my ABC notation. So remember, you can draw the diagram any way you want, but I'm going to purposely draw this so it doesn't have a right angle in it. Remember, these examples are going to be non-right angles. All right, now I can label the angles any way I want. Totally up to me. I'm going to label it as A down here, B up here, and C over here. Again, you can label it any way you want. You can put A at the top, you can put C at the top. It's totally up to you. But once you label the angles like this, you have to label the sides using the same letters where you put the lowercase a opposite the angle A. You put the lowercase b opposite the angle B, and I put lowercase c opposite angle C. Okay, so you always have to set up the triangle where the letters for the sides are opposite the same letter for the angles. All right, let's go do an example. I think doing an example would be good to see the setup here. So I'm going to jump to a WebAssign example here. All right. So I'm noticing here they're giving me three quantities as given. All right. So I'm going to draw a diagram. And again, for my diagram, I'm going to label these as ABC. So I'm going to replace these with a capital B, capital A, and a capital C. Again, you could use the Greek letters if you want. I just think it's a little easier to make these alphabetic characters. Notice how the sides are side A because this side is opposite angle A. Okay, remember, you got to set it up that way. All right, now I'm going to plug in or mark down on this diagram what's given to me. So I'm noticing here they're giving me that angle alpha is 39 degrees. Well, that's really angle A. So angle A is 39 degrees. They're giving me side A is 30 degrees. Side A is 30 degrees. I'm sorry, side A is just 30, not 30 degrees. Just length 30. Maybe it's 30 feet, for example. Let's say it's 30 feet. And they're giving me angle gamma, but remember, this really means angle C as 58 degrees.
Is it gamma or gemma?
I usually say gamma, but that's why I think this is confusing because, Janara, as you mentioned earlier, it almost looks like the letter Y, right? Yeah. So rather than use that Greek letter, I'm going to use capital C. All right, now I need to figure out everything else. So they want to know angle B, that's one unknown. Then they want to know side C, and they want to know side B. All right, here's the good news. Angle B is easy to figure out. Why am I saying that angle B is easy? Why is angle B so easy to figure out? Well, I remember that for any triangle, the sum of the three angles has to add up to 180. So if I know angle A is 39, and if I know angle C is 58, these three angles have to add up to 180. So that makes it easy for me to figure out angle B. So if I take 39 plus 58, that's 97. So it must mean that angle B is 180 minus 97. Okay, and 180 minus 97 happens to be 83. So I know angle B is 83 degrees. All right, so we figured that out. But now let's say we want to figure out one of these sides. Let me go to this formula. Here's the law of sines. And I'm going to circle what was given to me in the problem. Well, remember, they gave me angle A. They gave me side A. And they gave me this angle that I'm calling angle C. So notice I circled those three quantities in red. Well, now I could see the setup. Because if I set this fraction equal to this fraction, I know three of the four unknown quantities. So I'm going to go ahead and set it up as sine A over A equals sine C over C. All right, folks, I'm going to finish up in a minute. I know we're a little over time, but I'm just going to finish this up. Again, the reason I'm setting up the equation this way is angle A was given, side A was given, angle C was given. The only unknown quantity in this equation is side C. So that means I can easily figure this out. So let me plug in. This is going to be sine of 39 degrees over side A, but that was given to us as 30. And that's equal to sine of C, which is sine 58 degrees, over side C, which is the unknown quantity. But this is one fraction equal to another, so I'm going to cross multiply. If I cross multiply, it's going to be C times sine 39 equals 30 times sine 58. All right, one last step because I want to get C by itself. I'm going to divide both sides by sine 39 degrees. Because remember, C is an unknown quantity here, so I want to get C by itself. All right, well, I'm left that C equals this box that I'm circling in purple. So C equals this purple box. Well, this is a job for your calculator. So on your calculator, you have a sign button. And if you don't have a calculator that has a sign button, you can use many online calculators. So I'm going to type this into my calculator. It's going to be 30 times the sine of 58 divided by the sine of 39 degrees. And folks, it's a good idea to do this all at once on your calculator. Meaning, let your calculator work this out in one entry, on one line that you enter on your calculator. Now, I have to give you a comment. Make sure that your calculator is in degree mode. So most calculators, you can switch between radian or degree mode. So you have to be sure in these examples that use degrees, of course, You have to be sure you're in degree mode and not be in radian mode. If you're not sure how to check that, let me know and I can help you out. And if you would work this out on your calculator, I'm getting the answer 40.4269. But the rounding instructions, by the way, here we do have rounding instructions. The rounding instructions say just round to the nearest tenth. So the final answer for side C is 40.4. All right, so folks, here are the steps. We drew a diagram, carefully labeled diagram. Fill in on the diagram any of the quantities that you're given. Then start off with this law of signs formula. Circle the quantities that you know. That should tell you what two fractions to set equal to each other. Then once you have the two fractions equal to each other, you can cross multiply and solve for the unknown quantity. All right, folks, we'll do more examples on Friday. Sorry, I ran a little over here. Anyone have any questions?
No.
All right, folks, if there are no questions, feel free to log off. See you on Friday. I'm going to hang on for a couple of minutes in case anyone has questions. Remember, please look over the practice test for Chapter 9 so you can ask questions on that in Friday's class. In the meantime, of course, email me with questions. All right, folks, thanks for joining, and I will see you on Friday.
So 15 questions and 1 attempt for each question.
Exactly, for the test, yes.
Okay.
Yep. All right, folks, if there's no questions, I will close out the meeting. And thanks for joining.